I'll talk about a little bit of it since it impacted both my travels over the weekend, since I was unfortunately traveling through Chicago O'Hare, and then had a big severe weather event for April in Pennsylvania. I'll talk a little bit about what went on yesterday in Texas and Oklahoma, talk a little bit about the current weather setup down in the southeastern United States today, give a short-term forecast for the East Coast for Friday, mainly with flooding and severe weather being the main threats. Go over a bit of the medium range forecast. What can we expect in the next 1 to 2 weeks? Primarily focused on severe weather, but we'll look at other interesting things as well. And then just a long range severe weather forecast, kind of a shot in the dark, since the science is not real good on this yet. But what can we expect if we're going chasing in the next month or so, between the Storm Chase team and then myself and Dr. Markowski and the field project that's going on. So looking at what was going on April 14th, these are the synoptic charts for 12Z in the morning on Sunday. You can see a pretty strong low at 500 millibars and the attendant 850 millibar low right in the baroclinic zone, located kind of over the Missouri, Paducah, Illinois tri-state area. Strong warm and moisture advection, temperature and moisture advection out ahead of the front. And then Chicago is actually kind of located on the left exit side of the jet, favoring subsidence in that region, which inevitably led to some snow. I think O'Hare got something like 6 inches of snow on that day. We can see Pittsburgh and most of Pennsylvania is on the cool side of the stationary boundary, a strong cold front pushing through the southeastern United States. And there's even a slight inverted trough at the surface here just over Chicago as well. Looking at the morning soundings, Davenport, Iowa was as close as I could get to Chicago. The wet bulb is just below freezing. So actually most of the area was above freezing on that morning. They wet bulb below zero, and the precip was just so heavy that they had 6 inches of accumulating snow, or 5.5 at ORD. My brother was there for the entire event because he got in right before all the snow started. He was just sending me pictures of snow falling constantly on the airplanes. So yeah, strong northerly winds just above the surface. Usually coming off the lake in Chicago, that would keep you a little bit warmer. And the HUR actually had temperatures of 36 in Chicago for most of the day, so I thought it would be okay. But that ended up not being the case. The HUR's not always right. And then this is in Pittsburgh. You can see that the kinematic profile is actually at least moderately favorable for severe weather in the presence of CAPE, but we don't really have much CAPE at the surface. We're going to need substantial moisture advection and some warming, either diabatic heating or warm advection, or both going on at the surface to make us more favorable. So just from the snowy side of the system, they got 5.4 inches at O'Hare, which is a daily record. Here's a picture of all the people stranded at O'Hare. This is from some picture I grabbed off of Twitter that showed the snow, and it was pretty deep. I canceled my flights through O'Hare, so I decided to drive through basically the entire Upper Peninsula of Michigan and down through the Lower Peninsula of Michigan and try to get home. And we were forced to stop in Gaylord, Michigan, which is just north of Houghton Lake, Michigan, who had 8 inches on the ground. I was driving through 3 inches of snow, and my car just didn't really want to go much farther, so we stayed for the night. But here's the sounding from Gaylord, Michigan, a couple hours before I drove through. Strong north winds at the surface, just above the surface. Very saturated profile all the way up to basically the tropopause, pretty much, with a dendritic growth zone between 12,000 and 17,000 feet, I think. It was snowing hard, it was fast and accumulating quickly, and in April they don't plow snow very much because they've converted most of those trucks into repairing roads, damage from the winter. So snow removal is pretty hindered this time of year if you get a big snowfall event. 8 inches at Houghton Lake was also a record for that date. I think their prior record was like 2 inches. Going into the Pennsylvania severe weather event a little bit, Pittsburgh actually launched a special sounding, which is pretty rare that an office around here launches a special sounding for a severe weather event, but they did do one. And CAPE is not entirely impressive, confined to about the lowest 5 kilometers. These were probably pretty shallow thunderstorms. The kinematic profile is impressive, 53 knots of 0 to 1 kilometer shear, 0 to 1 kilometer SRH over 500. I think it's actually approaching 600. I think it's 585. But only about 430 joules per kilogram at CAPE. Luckily, we're strongly forcing parcels from the surface along that cold front that came through. On the right is the 0Z sounding, which terminated just above 5 kilometers. I don't know if it got struck by lightning or got pulled into the convection or what happened. But still quite a bit of CAPE, and I imagine there's about 500 joules per kilogram at CAPE or so. The kinematic profile not quite as good, but the the shear in the lowest levels is pretty much all parallel to the front. But with this much SRH in the environment, there's a decent chance for some spin-ups, which we did end up seeing within the line. Looking just at the synoptic charts at 0Z, still the strong cold front and attendant squall line out just ahead of the 500 millibar trough, and pretty much right along or just ahead of the 850 millibar cold front as well. You can see that the 850 low is translating up the baroclinic zone just along basically the Canada-U.S. border, located right over Lake Erie. And then also the surface low has moved towards the northeast as well, coincident with the 850 low, located right over Cleveland, Ohio. Squall line just about to pass through Pittsburgh at this time, with all of Pennsylvania being in the warm sector. So favorable air mass modification going on ahead of the squall line. We have moderate instability at least. So that we had the necessary ingredients, strong kinematics with just enough thermodynamics to get the job done, which it's April, so we don't expect the thermodynamics are going to be quite that great in Pennsylvania yet, although it does happen from time to time. So last count, at least as of yesterday, according to Jeff Jumper from the Pennsylvania Emergency Management Association, we've had 9 tornadoes. I think the office here is looking at 1 or 2 other areas that they may deem to be tornadoes, but actually 2 EF2 tornadoes, 3 EF1s, and 4 EF0s so far. Most of them in northwest and then northeast Pennsylvania. Just from recent memory, within the last year, it seems like we've had a lot of tornadoes, both in northwest and northeast Pennsylvania. When I first came here, people told me that southeastern Pennsylvania was kind of the hot spot to find tornadoes. Really hasn't panned out very much since I've been here. I've seen a couple of pictures, but nothing at least worth driving down there to see. And I'm really not looking forward to going in either in the Poconos or up in the northwest to try to go storm chasing. So it's just too hard, too much. But SPC did a great job highlighting the risk area. And then I saw Andrew Markowitz called a power flash, indicating just the strong winds just north of State College, probably pushed a power pole down or something. So I thought that was a nice find. I heard he was looking the opposite way of everybody else when the storms were coming in, happened to catch it. So yesterday, there was a kind of almost bimodal severe weather event. One along the cold front stretching from northern Oklahoma up into eastern Iowa with enhanced risk for moderate wind. And then this was taken a little bit after these initial supercells formed out in the Texas Panhandle. So I believe the risk area actually included most of eastern Texas Panhandle as well. And then there was another risk for along the dry line and then surging cold front later at night for an attendant squall line. So yeah, didn't really pan out as played as much. The squall line ended up being a lot weaker. There weren't quite as many severe weather reports, although I imagine more will trickle in today. Oklahoma saw their first tornado of the year yesterday, which seems kind of late, April 17th. But it's earlier than it was last year. I think last year they waited until May 1st to get their first tornado of the year. Not the greatest looking funnel, looks pretty wet there. But you get what you get sometimes when you go storm chasing, and someone saw that. I wouldn't have been my play for the day, but people got it, and it looks pretty good. So anyway, we'll take a look at the radar loops real quick for what happened over on Sunday. So you can see all the snow through basically over Lake Michigan, Chicago, and then up into the central and northern lower peninsula of Michigan. We see initiation along a couple of boundaries here. There's some discrete cells early on. There's basically all of the stuff. I don't know if this was the cold front back here, and then it kind of got taken over. But the leading storms ended up being the dominant mode for the most part. Kind of line echo wave pattern forming here through northern Pennsylvania. I imagine at this time or when the tornadoes were either ongoing or about to be ongoing. And then if we switch over to the next day, because of how this radar site works, you see that the line, it progresses into Pennsylvania. The northern part remains fairly strong, and then the central part actually strengthens as it moves into central Pennsylvania, which is somewhat of a rarity. But I didn't look too closely into it, but I imagine the cell motion was at least somewhat from the south within the line, since that seems to promote stronger storms here in Pennsylvania. As opposed to a strongly due westward motion. Coming off the plateau, you just get, I think, enhanced SIN, decreased relative humidity, and the storms seem to kind of die in the sinking motion before reinvigorating about a county over from here. And then squall line intensifies again as it moves through. Here it looks like, I mean, this is 9Z. And then it looks like it actually flares up a little bit as it moves into the Gulf Stream, where you have higher theta E air and more Cape. Kelly Lombardo out of UConn does some really nice work on these kind of squall lines moving off the mid-Atlantic coast into the coastal regions, and the stability of the water and the Gulf Stream play a large role in the propagation of these squall lines coming off the coast. Looking more at today, the focus today, at least for severe weather, seems to be down along the Gulf Coast in eastern Louisiana, southern Mississippi, and southern Alabama. I don't know if this is the most current image. Kind of in the region of focus down here, pretty socked in with clouds, but out ahead of it, we actually have good diabatic heating just along the coast. You see some of these cloud streets indicating probably moist advection. It looks like there's maybe a gravity wave or something propagating through the moist layer. But your region with strongest Cape is not actually seeing a lot of the solar heating right now. So it's probably primarily marginal lapse rates combined with large moist advection occurring just ahead of the front. I haven't looked at what the radar looks like down there in quite a while, but I imagine, how would if they just changed their site up a bit since I've used it. Yeah, it used to be able to overlay radar.
Yeah, next to Cape.
Oh, there it is. Yeah, so the squall line is still, there's decent Cape ahead of the line, but it hasn't encountered the region where we've seen some solar heating yet. But there was, at least at some point today, a 10% risk for tornadoes. I don't know if that's still the case. It looks like it is. Kind of a messy setup. I don't know how many tornadoes I really see coming out of here. I could see a lot just given that the thermodynamic or the kinematic profiles are so strong in the lowest levels. It's very similar to the kind of the Pennsylvania event we had, where you have quite a bit of SRH in your environment. LCLs are going to be really low, so you get some brief spin-ups at least. So we've got strong theta E advection going on ahead of this mesoscale convective system that's still ongoing from last night that pushed through Dallas-Fort Worth and most of East Texas. Didn't quite live up to the media hype. I don't know how many of you saw the pictures from some of the Dallas-Fort Worth area. People were literally strapping air mattresses to their cars and putting bags of mulch over their windshields to try to protect their cars because the media had hyped up the large hail. And then tried to have some explainers this morning as to why the stars didn't produce the strong hail that they thought would occur. I don't know. Their explanation to me didn't make a ton of sense. But I think at some point you just have to tell people some scientifically plausible explanation, because when you have people strapping air mattresses to their cars trying to protect their windshields and it doesn't happen, they may not take the same precautions the next time. So I think when you bust a forecast, it's always important to dig into why and tell the public why and have transparency. And I thought they were at least some of them were trying to do a decent job with that. But I know I have a lot of friends and family in the area, and I know there's a lot of kind of media hype before the event that led to maybe some unnecessary panic. Looking at the HER for the rest of today, when I like to forecast convection, one of the things I like to look at first is theta E. It gives you a sense of where you have kind of deep, moisture-rich air. And you see that you have theta E's pretty much increasing and being affected off the Gulf of Mexico just ahead of the cold front. By 0Z, the cold front's still lagging behind a lot of the convection. Where the convection is now, it doesn't progress very, very quickly throughout the day. But kind of you would expect just into southern Alabama to be kind of the focus for most of the severe weather, with a sharp cutoff here along some kind of boundary, probably the cold front through northern Alabama. So pretty much the southern half of Alabama tonight. If we look at a point sounding out ahead of this line overnight, we see really strong kinematics, pretty streamwise vorticity being ingested by this squall line. Cape is actually pretty favorable still for this 5Z, so that's quite a bit of Cape in my eyes for 5Z at night, but pretty saturated profile with a dry layer in the mid levels. So there's moderately buoyant parcels being ingested with quite a bit of streamwise vorticity, so that whenever you have that, I think that there's definitely tornado potential with the squall line as it progresses through Alabama and Mississippi tonight, through basically the risk area that SPC has outlined. Stepping the simulated reflectivity through time, we see that there's storms that kind of develop out ahead of the main line, and they actually take over as the primary squall line here, it looks like, before dying out, and then some semi-discrete cells actually are able to form behind that. So it'll be interesting to see if this line out ahead of the convection either stabilizes the environment and convectively overturns it, or if this is 5Z when I plucked that sounding from somewhere out in here, and there was still 1,200, 1,300 joules per kilogram of Cape. So it doesn't seem like the environment's too affected by the early convection, which seems to be characteristic in the southeast. I'm not quite sure why. Sometimes it stabilized the environment, and other times, like on April 27th, 2011, where there were 3 different MCSs, and none of them really stabilized the environment. It may just be that the lapse rates are so steep and there's so much moist advection that you can kind of overcome some of these things that maybe in the Great Plains you can't always overcome. Proximity to the Gulf of Mexico and land surface modification may all play roles as well. Looking ahead to tomorrow here in central Pennsylvania, the primary risk, I think, is a flooding threat from heavy rain. We have really high precipitable water air being evected up the East Coast. But it does look like that there are a chance for at least some thunderstorms here in the area tomorrow afternoon or tomorrow evening, looking at a point sounding. There's some Cape, and 0 to 6 kilometer shear is actually pretty high. 70 knots, that's definitely more than sufficient for supercellular type storms. Just enough Cape, about 5 to 600, somewhere in that range. So it wouldn't surprise me if there were some initially discrete supercellular-ish structures on Friday or tomorrow afternoon, rather. It'll be interesting to see kind of what happens with this kind of, there's no cap and some moderate amount of forcing, I bet. So I could see a lot of convection lighting up, or I could see not much. 3 kilometer NAM is not incredibly favorable towards widespread heavy precip like the GFS has been showing for quite a few days. It has almost a more of an isolated convective mode. Looking at total QPF, where you do get storms, you're seeing upwards of an inch and a half of precip, and where you don't, there's actually some spots that stay dry, whereas opposed to the GFS, which had widespread 1 to 2 inch rainfalls. So it'll be interesting to see how this plays out tomorrow. Cams don't always win, but they seem to be suggesting at least more isolated instead of widespread rainfall tomorrow. Centered actually on central Pennsylvania in the I-99 corridor, or just east of there. Let's see. So I was looking at where the moisture is coming from for this system, and it's actually got pretty deeply tropical roots, both in the subtropical Atlantic. There's kind of this low, or actually it's the North Atlantic high, is advecting moisture towards the east, and that's meeting up with deep moisture coming from the Caribbean and also even the East Pacific. So as far as atmospheric river events go on the East Coast, this is about as good as we get. It's not very prolonged or sustained, but it is similar in nature to an atmospheric river that you would see on the West Coast. Just you don't have as long of a region of moisture transport. So you don't quite get that fire hose effect maybe that you would out in California. We also don't have mountains that are at 14,000 feet wringing out all the moisture and getting 10 feet of snow in one event. So yeah, I think where we see storms, you could get up to 2-3 inches of rain, especially if they're slow moving tomorrow. Hard to tell though if widespread heavy rain is actually going to occur. Looking forward, the next couple of weeks here, we see kind of this cutoff low that forms on the East Coast. Really not the greatest weather this weekend. Sticking around, Easter looks to be slightly wet and cloudy and kind of cool. Moving a little bit forward, that low progresses off finally after sticking around for a couple of days before another cutoff low forms, hangs around over the East Coast. Maybe an initial round of convection here towards the end of next week. Before it sits around and we have more kind of rainy, miserable weather, it looks like. Beyond that, I don't know how much I trust the GFS. It looks like it pushed another cold front through and just remains kind of unsettled for the most part for the next 2 weeks. Seems to be favoring cutoff lows right now with the pattern primarily zonal flow. So we'll see what happens. It's not an ideal end of April, but it's better than snowing. I think last year around this time we did actually see 2 or 3 inches of snow. So yeah, I'll take that any day. Looking for where we can expect to find severe weather over the next 2 weeks. Outside of Friday, down through the mid-Atlantic and up into central Pennsylvania. I think our next decent shot is maybe Sunday evening, kind of along the triple points in central Kansas. You have a high theta E air mass. The only problem is wind shear is just abysmal at this point. Maybe down into central Oklahoma, you might find a little bit better wind shear at the base of the trough. It's really hard to say though. Not looking too incredibly favorable. The air mass sticks around, but the shear does not. So really, it's looking quite poor at this point. The cold front pushes through before we get another high theta E air mass advecting into the plains. Again, you see some veering of the winds with height, but the flow is not particularly strong anywhere. Your high theta E air mass does stick around. It looks there's some hint of a dry line here and maybe some enhanced flow at 500 millibars, but I wouldn't call 30 knots really enhanced. The GFS does want to keep Cape around, which is a promising sign at least until a cold front crashes through late in the period potentially. But it doesn't actually wipe out all the Cape, and you can actually see at the surface we're taking kind of the Rio Grande River approach to ejecting moisture back into the plains, which might get you out in New Mexico if you're chasing, what is that? I don't think anyone's going out May 4th. But looking forward, that's what we can look to maybe see severe weather. I wouldn't say that there's a ton of chances. I don't have too much more time left, but looking at atmospheric angular momentum, this is basically a relative measure of how trophy or zonal the flow is. So positive numbers indicate that your flow is more zonal, and negative numbers indicate that you have more long waves embedded in the flow. So we've been stuck in this high atmospheric angular momentum regime for most of the winter now. Has decreased slightly, but it's not really decreasing into negative terms yet. In May, you tend to see more negative pattern favor, which means that we're getting more troughs. When it's negative, you have the potential for a trough to set up over the Rockies and get your severe weather events. It's just hard to say when we're going to transition from positive to negative. Victor Gensini does a lot of great work with this. A lot of his research is in kind of sub-seasonal severe weather forecasting. This is another tool he has where it looks at the GEFS and basically composite SCP and anomalies. So if we look at SCP anomalies, SCP across the CONUS remains anomalously low for the next 2+ weeks, indicating that chances for severe weather really aren't that high. Members tightly clustered even out to 2 weeks. So I think the next 2 weeks look pretty unfavorable as far as getting severe weather really anywhere in the United States. I could be completely wrong, and some convection somewhere could change the entire global forecast system to produce something else. But we'll see. Looking at State College just for the next couple of days, today looks like really the best day for the foreseeable future. Tomorrow we get up in the 70s, maybe to 70, but we'll have rain start falling in the afternoon. Saturday, temperatures in the mid-60s before the cold front comes through. Sunday just looks terrible for Easter. But we rebound a little bit into next week. Next Monday and Tuesday shouldn't be bad before another chance for rain, I think into Wednesday. Looking ahead to some sub-seasonal tornado forecasts, like I mentioned, Victor Gensini and some others tend to look at events going on over the globe and kind of link them to tornado outlooks. So they have forecasted for week 2 and week 3 average conditions, meaning that we should see somewhere about average counts for tornadoes in week 2 and week 3, and they've highlighted kind of the southern plains from the 21st into the 27th. Their reasoning for this is that kind of the models were showing a long wave returning into the U.S. And then for week 3, that they're thinking that the MJO may start up again. If you've been looking at the MJO, it's really just been in a very neutral phase near the center of your phase diagram. It really has not wanted to come out. We haven't seen much convection in the Indian Ocean. They're thinking that during the end of April, we may see a convective burst in the Indian Ocean, which would push an MJO wave around the globe, and you may see some wave train propagation in the mid-latitude that may lead to favorable conditions for severe weather in the Great Plains. But that remains to be seen, given that if we look at some dynamic MJO forecasts, really they remain quite weak. And even though you do maybe start to see some convection in the Indian Ocean, that really remains in the center again and comes back into the center. So maybe we might see some convection, but you won't get the strong wave that propagates with the MJO like you traditionally see, where it comes out and it rotates through all your phase space. MJO is not my specialty, but it's interesting to look at, and it's definitely an important ingredient in long-term tornado forecasting. For those of you that like to look at the CFS, we'll just fast forward beyond the GFS, and pretty weak flow through the central plains, although we do see a long wave start to come in towards the beginning of the period. So if you're in the plains by May 8th, 9th, the CFS likes your chances, at least in New Mexico or Texas Panhandle. I don't really buy much into this CFS, but I think it's May. You've got to get a trough out there at some point most of the time. But after that, really just kind of weak flow, northwesterly flow, even through a lot of the Great Plains, before maybe you start to see a subtropical jet come in, and then you could get another episode towards kind of mid to late May again. None of this has really been consistent in the CFS, so I hesitate to even show it. But there are at least some signs that you may see some transient troughs out west. Looking at SCP from the CFS, it's not clear that there's a strong signal or preference for severe weather through this time, but SCP does remain elevated, so at least there's probably some cape somewhere in shear. So you'll have chances. It's not showing that a depth ridge is going to set up or anything quite like that. Looking at the last 11 runs of the CFS, we'll go out to, this is May 9th through May 16th. We see an indication of a trough just off the coast of California with a ridge over the eastern Rockies. And same into kind of the last couple of weeks of May. That pattern seems pretty consistent. So it seems possible. I would expect a fairly average year for severe weather, but average doesn't really mean much. It's not really a forecast either. It's just hard. It's hard to kind of pin some of this stuff down in the long run. And even though you could have an incredibly below average severe weather year, but one event could make the year just seem completely above average because it hits a populated area. But overall in numbers, we're pretty much at the 50th percentile for tornadoes. EPS is showing a pretty similar thing to the CFS for what that's worth. It does have a trough, maybe a little bit farther east, where we'd like to see one for severe weather and storm chasing. But kind of mid-May, it actually has quite a strong ridge over the central plains, which if this flow pattern is right, you may be looking at going into kind of similar regions where I chased with the storm chase team last year up in Nebraska and Wyoming. But that's 3 weeks away, so I won't say any more about that. That's all I have. I think I'm 2 minutes over. I'll take any questions if you have them. Otherwise, I'll let you get going with what you have next.
Any questions for Branden? All right. Well, thank you very much.